Student, I hope you understand the mole concept and the molar mass. Now we go to chapter 12.3, the calculations involving moles and masses, and also the first part is a converting between moles and mass. So before that, let's see the example on the right hand side. So given molar mass of carbon is 12 gram per mole. 12, okay, we know it's the same, the value is same as the relative atomic mass of carbon, which you can find from the periodic table, right? And then given mass of carbon is 24 gram. So because we know that 1 mole, there are 12 grams, now we have 24 grams. So I want to ask how many moles of carbon, so that we just simply use division, then we can find out the number of moles of carbon, right? So number of moles of carbon is equal to 24 gram divided by 12 gram per mole. 1 mole we have 12 gram, that means how many mole in total we have. So this division, actually we know that gram and gram we can cancel out. And gram and gram cancel out, and then 12, and then leave 2, 1. So 2 over 1 mole negative 1. Then the final answer should be 2 mole. Okay, how can we get this unit? Now you can check the right hand side. Gram per mole actually can convert it into gram divided by mole, right? Can you see that? And also let's see the right hand side, this part. Let's see one by one. Okay, so 24 gram divided by 12 divided by mole, right? So 24 gram divided by 12 gram divided by mole, right? So we can convert into like this. So 24 gram can divide it by the whole thing, 12 gram divided by mole. So we divided by a fraction, then this fraction we can convert into, when we times it, we convert into times, then the fraction will be upside down, right? So mole now become mole divided by 12 gram. So now mole divided by 12 gram, so gram and gram can cancel out, and then 24 and 12 can also simplify, so that the final answer is 2 mole. So I hope you understand the unit, the conversion of the unit. So therefore, if you want to find the number of moles of substance, actually you can use a division by using mass of a substance divided by molar mass of substance. So you can check the unit. So mass of substance, the unit is gram, and molar mass of substance is gram per mole, right? So gram and gram can cancel out. Now leave 1 over mole to the power negative 1. So actually the unit is mole. The number of moles, the unit is mole, right? So I hope you understand this. Now this equation actually can convert it into another equation. Now you can see that if we want to find out the mass of substance, means that the numerator, then we just simply use the number of moles times the molar mass of substance. Then according to the unit, you can check, we use multiplication, that's mole negative 1 and mole can cancel out, so leave gram. So you can find the mass of substance, the unit is gram. Okay, so also this equation can also convert into another equation. So that is, if you want to find molar mass of substance, we don't find the parameter of the denominator, then we just simply use mass of substance divided by number of mole of substance. So gram, you can see the unit now, gram divided by mole. So gram divided by mole actually is just mole, gram per mole, right? So gram per mole, you got it. So for later on the calculation, just simply use the equation directly, or just convert the equation, and then you can find different parameter. Okay, let's see the example 12.12. How many moles of phosphoric acid molecules? The formula is provided, and then in 84.3 gram of acid. So ask you the question, ask the mole of, that means ask number of mole, and then what's given? Given the mass, right? So gram, given mass, and given number of moles. So according to the previous equation, you just simply use a equation. Do you remember the equation? Use mass divided by the molar mass, then you can get the number of moles. Now we have the mass, we don't have the mole, okay? But the molar mass, you still have. The molar mass of this phosphoric acid molecule you still have. This is a molecule, so that the relative molecular mass just simply add all the relative atomic mass together, like for this molar mass, 3 hydrogen and 1 phosphorus and 4 oxygen add together, so that the final molar mass is 98 gram per mole. Then you use this equation, mass divided by molar mass, so that you can get 84.3 gram divided by 89 and 98 gram per mole, so equal to 0.86 mole. So you got the final answers. Okay, then let's see the next example. So what is mass of 0.076 mole of aluminum sulfate? So let's see what's the question given. The question given mole. Mole is given, but the mass we don't know, right? The mass we don't know. And aluminum sulfate. First of all, you need to convert the name to formula. So aluminum sulfate. So it's actually it's ionic compound. Aluminum sulfate. So aluminum we know in iron form is Al3 plus. Sulfate we know is SO4 2 negative. And then you can you see the charge is not balanced, so that I saw some of you they use a cost method like this. Cost method. So 2 put it here, so become Al2, and 3 put it other side, so become SO4. Because it is a polyatomic anion, so that we use brackets 3, okay? Or you use Al3 plus sulfate 2 negative, and you find that the charge is not balanced, and then you need to think of how can you balance it. Then you put 2 in front and put 3. So when you write the formula, just simply hidden the coefficient. So Al2 SO4 bracket 3. Okay, so do 2 method up to you to convert the name to the chemical formula. Okay, actually the formula is given here. So now, given mole and ask mass, so you can check the previous equation. Actually, the previous equation is you can refer to the above. Actually, number of moles equal to mass divided by molar mass, right? So now the question asks you the mass. Then you just simply use the molar mass times the number of moles, right? So molar mass of this formula unit of aluminum sulfate, just simply add all the relative atomic mass. Then you can find it. So 2 aluminum and 3 sulfates iron, so that 3 times brackets, and then sulfur plus 4 oxygen, so that the formula mass actually the value of the formula mass equal to the molar mass. So molar mass is equal to 342.3 gram per mole. Now you have molar mass, and you also have the number of mole. Okay, so that just simply use the equation. Number of moles times molar mass, so number of mole times molar mass, so that you can check the unit as well. Mole to the power -1, cancel mole, so that you leave the answer gram. So gram is mass. Okay, so now the mass, you find it already. Okay. Okay, so after you understand the example, so you can go home and do the practice. After that, then you can check the answers. Okay, I think this table is very important because it can help you to even more understanding the internal conversion of the equation. Okay, how can you find the mass? How can you find the molar mass? How can you find the number of moles? So okay, do practice for this table. And let's see the further examples. So calculating the number of particles in a different mass. Okay, so actually there's two equations we have learned, two main equations that we have learned. So the first equation we have learned before in the previous chapter is, do you remember that the total number of particles actually equal to the number of moles times the Avogadro constant, 6.02 times 10 to power 23, right? So we just simply use number of moles times Avogadro constant, then you can get number of particles. That's the first equation we have learned before. But now in the previous chapter, we just learned another equation that can find out number of moles. And that we use mass of substance divided by the molar mass of substance. You still can find the number of moles, right? This is the second equation we just learned. So mainly there are two equations, but actually each of the equation can do interconversion, right? So one equation can separate into three different equations. So there become many equations. So if you can understand these two equations, then the other equations, suppose you can still understand. Okay, let's see the following examples. A beaker contains 82.8 grams of water. Now ask how many molecules. How many molecules? Water molecule. That means that the amount, asking you the total number of molecules, right? Then how should we do? This question given the gram, given mass, and ask the total number of particles or molecules. These questions, but we don't have a direct equation related to mass and number of molecule. Okay, so we need to, this question we have two steps. The first step, we need to find out what's the main parameter we should find out. The main parameter is the number of moles, right? So firstly, or normally, we need to find out number of mole. So number of moles we have to find out first. Number of mole of water. By using the equation, you have the mass divided by molar mass. That means that you use equation 2, you can find out the number of moles. So once you find out the number of moles, then you just simply total number of molecules actually equal to number of moles times 6.02 times 10 to power 23. Then you can get the final answer. Okay. Okay, in the part B, the question asks how many atoms in water, right? So to ask you the total number of atoms. In part A, we know that the total number of water molecule, we know it. And by part B, we know that one water molecule actually it contains 2 hydrogen atoms and 1 oxygen atoms. That means there are 3 atoms in one water molecule, right? So that the total number of molecules just times 3, then you can get the part B answers. Okay, so now okay, let's see the answers. Okay, part A, the question asks you how many water molecules in it, right? So given mass, and also actually molar mass you can find from periodic table. You just simply add all the relative atomic mass then of hydrogen and oxygen. You can find molar mass of water. So 82.8 gram divided by 18 gram per mole. So gram and gram cancel out, so leave 1 divided by mole to the power -1. So the final answer is 4.6 mole. So the total is 4.6 mole. Find out the number of mole first. And then the final part is because the question asks you to find the total molecules, the total number of particles, so that we use the previous equations. Okay, so use number of moles times the Avogadro constant, so times 6.02 times 10 to power 23. Then you can get the total number of molecules. So you can see mole to negative power -1 and mole cancel out. So you remember that the total number of molecules is 2.77 times 10 to the power 24. Okay, you don't need to write any unit in it. And then for part B, because we know that each water molecule contains 3 atoms, so you just once you know the total number of molecules, then we know that each molecule contains 3 atoms, so just simply the answer times 3. Then you get answers, right? Total number of atoms, just times 3. Okay, I hope you understand the equation. And then the example is not really difficult actually. And then there's some exercise, go on to do it. And after finish it, I think you understand the previous 2 equations. So those 2 equations, they have an interconversion. So also you need to understand it. Okay.